This call is now being recorded. This call is now taking notes.
All right. So a distance time graph, it's more like a graph that shows the distance an object has traveled, right? So that's what a distance time graph does. It shows us the distance that an object has traveled, right, against time. So they can also be referred as your travel graphs. I wish this thing loaded so that I'll not be copying so much notes, right? Just to make the whole thing easier for ourselves. But in the absence of that, let's just go. So later on, I don't think we can copy note now. So it just shows you the distance an object has traveled against what time. Um, Key things you need to know about your distance time graph, right? So for example, let's say we have a graph like this, and I'm going to label them. I don't think you need that definition, but what I said, I go again that distance time graphs are graphs that show the distance an object or a person has traveled against time. So more like you are trying to see how you've moved. So that graph is trying to show us, okay, this person has moved from a particular point to a particular point. So they show us the distance an object or a person has traveled against time, right? So, and the y-axis of this graph is the distance traveled, while the x-axis is the time, right? So that's why we call it distance time graph. So you're plotting distance against time. So let's just plot a graph this way. So you have a line running through this way. Let's just say something like this. Then you have another line running through this way, something like this. So it means that you have your distance, which can be in meter, it can be in kilometer, it can be in millimeter, whatever thing the unit, whatever unit it is given, it can just be that. So remember that this side of the graph represents your distance, which can be in kilometers, it can be in anything. Why this side of the graph happens to be your time, as the case might be. So this is your time. Remember, the time can be in seconds, it can be in minutes, it can be in hour, depending what you are given. So now, what are the things I want you to know regarding your the distance time graph, right? Um, when you take the gradient, I'm going to explain. In secondary school, you learned about taking slope. All of us are science students. In as much as I know that some persons copied graph, but you didn't copy the slope. You can copy slope as well, but at least you heard about slope. Slope is something as gradient. So when you are plotting distance against time, the gradient of the slope of the gradient of that very graph is going to give you the speed. Do you understand? So now, what does it look like? We can actually get the speed from the distance time graph, right? So now let's look at a particular diagram and then let me label accordingly. So let's say we have here to be 0, right? Let's have here to be 10. Let's have here to be 20. Let's have here to be 30. Here 40. Here 50. That's for our distance. Remember that this side is the distance. So let's have the other side to be our time. Let's say we have 12 o'clock, right? Let's say we have 13 o'clock, which is 1 o'clock. Let's say we have 14 o'clock. Let's say we have 15. Let's say we have 15 o'clock. Let's say we have 17 o'clock. Now, this is how the graph might look like, your distance time graph. Are we together? So let's say that someone traveled. Let's move. Let me take it from here to here, right? Let's just take from here, take a straight line downwards to this place. Let's say that person traveled this way for some time. Let's say the person continued this journey up until this point. And then if you one of the reasons why you shouldn't sleep in this class today is the kind of stress I personally have gone through. But immediately I started this class, it's as though that there's this energy that just entered just that way. So that's one thing about teaching, right? You might be tired, but immediately you start, there's this energy that comes from somewhere that immediately you start enjoying it. I don't know whether it's personal, share. I don't know whether it happens to only me, but there's this kind of energy flowing within me currently that I don't know where it is coming from, basically. So if anybody sleeps in this class, then you have a spiritual problem and you should be delivered. Okay, guys, let's go down. Sorry, this is not straight enough. Beautiful. So let's have this. Now, when you have that straight line, what this straight line is telling you, let me label them. Let's label. Let's have here, sorry, I'm using the wrong label. Let's have here to be our A, have here to be our B, here to be C, or rather, let's use something more tangible. Let's call here A, call here B, here C, here D, and here F, E rather. So something is happening at every point in time. And that thing that is happening should be tracked at every point in time as well. Now, when you see something like this straight line, when you have a straight line like this, it simply means a constant speed, right? And from our graph here, we can say that this guy is traveling at constant speed of what? 30 kilometer per hour. Do you understand? So let's say that this my line here is kilometer. Let's say we have here to be kilometer. That's my distance. Then let's say that the time here is hour, right? So you can see that this guy traveled for a constant speed, like traveled with a constant speed, a straight line, right? So once you have a straight line, it simply means that what you have right there is a constant speed. So from 0 to A represents what? Constant speed. So let me quickly write it there accordingly. Constant speed. So once you have a straight line, you have a constant speed. And that's why I took time the last time to explain some of these concepts. I explained what I mean by a constant speed the last time. So you are traveling, you are covering equal distance at equal time. That is constant speed. Equal distance at equal time. That's what you are doing. And that's exactly what we spoke about the last time, about when speed is changing and when speed is constant as well. If you're with me, can you give me a thumbs up? A thumbs up if you are still with me. How will I even see the thumbs up I'm requesting for? Okay, okay, okay. Well done, guys. Well done, great people. Beautiful, beautiful. Yeah, don't sleep, eh? Stay with me. The Lord will strengthen each and every one of us. Strength is available in the house. A lot of strength. All right, so that's constant speed. Then from A to B, when you have a flat line like this, right? Pay attention, people of God. When you have a what do you call it? Slanted line, a straight line like this, it means that the body is not moving. It means that the body is stationary. It is not moving. That's what that line from A to B represents. But from 0 to A, once you have that slanted line, right, it means that it's a constant speed. But once you have a straight line this way, right, it means that horizontal line, it simply means that the body is not moving. The body is at rest. The body is stationary. Why is it that way? When I start finding the gradient, you can see that you cannot find the gradient of a line this way. For some of us that did physics very well, you understand that if you have a straight line, you cannot find the 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 gradient of a straight line that way. So here you see that the object is stationary for this particular point, right? It means that the object is what? Stationary. In bracket, it is at rest. It is not moving. Now, again, you have a slanted line. This is also a slanted line. So that also tells you that you have what? A constant speed here. Or at rest. Now, if you check the constant speed that this guy is traveling at, just have to trace it this way. Just trace the line from here. Let me see if I can use a different color for some of us that might be confused. We just trace it to this place, from here to this place, which means constant speed there is what? It's traveling at a constant speed of what? 30 kilometer per hour. So once you trace to the y-axis, it gives you the speed, right? The same thing here. If you trace this 20, 30, 40, so that place will be 40, 45. Nobody's saying anything. Now, if one person says it now, you say, okay, I wanted to say it. 40 kilometer per hour, 45 rather. So this one now is constant speed, and the rate of that constant speed is 30 kilometer per hour. Right. Now, this time around, here as well,
I cannot hear you very well.
speed as well, constant speed. So that's how to actually represent. That's what these lines on the distance time graph represents. So each time you see a distance time graph, this is one thing you should always bear in mind, right? So when it is body is not moving, slanted hard line, it is stationary. When it is straight line, those all of those concepts are the key things you need to know about your distance time, right? You make use of the time, make use of the what of the distance. So now how do I get to find the what do you call it, the speed at every point in time? Now to get the speed, sorry guys, to get the speed at every point in time, what are the key things that we need to know? So for example, now let me erase these lines here. I've said that they are constant speeds, right? And I believe that you've taken note of that. So let me erase this as well, erase this as well. So each line, each point on this graph, you can calculate the constant, you can calculate the speed, right, of the object that is traveling. Here was B, here was A. So they can ask you to find the speed between point 0 to point A, right? Let's say you have the graph sketched already. They want you to interpret the graph. So how do you get the speed from the region or from the section body move from 0 to A? So what they are simply asking you to do is to find the gradient. If you know how to find the gradient of a line, that's a big advantage for you because it will make the work easier for you. So just draw a straight line, take it downwards. You know you can take any triangle at all, anyone that you think is convenient for you. It's entirely fine. And that person can decide sorry, and that person can decide to take just a short path from here, just from here to here. And that person can decide to do this. It's up to the person. So anyone that is convenient for them, they can actually go for it. Let me see whether this site has loaded. So it could save me stress. All right, beautiful, beautiful. Somebody say miracle worker. All right, so um I like the concept they used here, in as much as you guys are not writing GCSE, but I like the concept here, right? So quickly recap: distance time graphs are graphs that show the distance an object or a person has traveled against time, right? I've spoken about the things. Look at the key things. Yeah, that's the graph I was sketching for us, right? So constant speed, constant speed, stationary, and the rest of them. So I now want to show you how to estimate the gradient from the graph, right, at every point in time. So now let's proceed. Now, different slope, different persons can take, right? You can decide to take this, and that person can decide to take this, different choice, right? But for me, I like picking the ones that I can read out the values immediately without stress, right? And I hope we are still following, guys. All right, so I'm going to take my slope um, down here. All right, thank you. I'm going to take my slope down here, take it to this point here. Are you seeing it now? So with that, how do I now estimate? Remember the formula for your slope. That slope back in the days, back in the days, that the slope m is equal to y2 minus y1 all over what? X2 minus x1. That's how to estimate your slope if you can remember very well, right? Yeah. So if you do that, but this time around, your m is your speed because distance over time. Remember that speed is equal to your distance all over what? The time. That's the speed, distance over time. So if your speed is distance over time, what that simply implies is that your gradient of each of those lines here on this graph will give you the speed. So let's first of all, my God, estimate this very one and see what the slope is or the gradient is for the distance traveled from 0 to A, for the journey 0 to A. So for that journey 0 to A, right, the speed from the region 0 to A, for that very travel, 0 to A, for that very journey, we have that the speed is equal to, now trace your value. This is the value of your y1, y2 rather. So the value here is your y2. Now trace it to the origin where it stops here. The value here is your y1. Value here is your x1. The value here is your x2. If you know how to find your slope, these things will be easier for us. So now it simply implies that the speed for that very region, my y2 is 30 minus 0 all over what? You have 13 right there. But remember that what I used was time, right? In hour, 13 o'clock means 1 o'clock, 2 o'clock, 3 o'clock. Do you understand? So I'm not expected to use 13 right there. Do you understand what I mean? Give me a thumbs up if, but I think you should give it the same thing as well, basically. But I don't want to do that. I want to use the normal timing. Yeah, so you get the point. So I'm not going to use that 13 unless I am taking the difference between the two of them. So this is like time, clock, 12 o'clock, 13 o'clock. So in a good note, that this is 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours. Do you understand? So which means that this 13 is going to be what? Oh, let me let me quickly change this so that we don't get confused at the moment. But later on, you see what I'm talking about. This is 2, 4, 6, 8, 10. Or let's use 1, 2, 3 so that our brethren will not be confused. 1, 2, 3, 4, 5 hours, 6 hours, 7 hours. So it's going to be what? 2 minus 0. But sometimes, sorry guys, I don't know what's happening. All right, thank you. But sometimes they can change this thing. You are not going to be seeing 1, 2, 3. You're seeing the time itself because you are traveling. Someone left the house around 13 o'clock. That's 1 o'clock. Got to the house by 15 o'clock. That's 3 o'clock. So you subtract 13 o'clock minus 15 o'clock. That is how many hours? 2 hours. So you're going to see problems that way, and you should know how to subtract your time. So the speed travel for the first distance of the journey, the speed. Okay, confidence. Go ahead and ask your question.
Sir, sorry, it was a mistake.
Okay. Sleep don't come your eye already. Very soon now you go. So this is this is 15 meter per second. Because I wonder what your hand they find the raising hand button. No be sleep causer. All right. So speed is equal to 15 meter per second for the first region of the journey. So now the second region of the journey as well. I want to split this line so that we could have enough space to do this. So let's draw a line here for the first part of the journey. Now let's draw another line here. Second part just that way. Now, the next part of the journey you can see right here on the screen, to get the speed of that journey is from A to B. Like I told you, A to B, there's no how you can get the slope of A to B. So A to B, speed is 0. A to B, we'll have that the speed is 0. And if the speed is 0, maybe someone have raised hand, the other one have raised hand as well. Okay, sleep is coming. So A to B, that's 0 meter per second, means that the object is not moving, right? Is the raising of hand to ask question or what? Confidence, your hands are up. Meso, your hands are up. You want to ask question? Okay, go ahead.
Okay. So like my network disconnected the call and I came back and I'm seeing 1, 2, 3, 4 times on the graph.
Okay. Okay, it was 13 before, right?
Yes.
Okay, what happened? I was trying to explain something that the 13 I used before was the normal timing on a clock. But right, sometimes they will give you that. And I was trying to say that if you want to subtract, let's say 13 o'clock, you left the house around 13, go to the location by 15 o'clock. That means 13 minus 15, that's 2 hours distance, 2 hours journey. So but I said, let me use this timing so that I will not be confused. Let's change the scale. But with time, when I
Okay.
start solving questions, you understand why I was making reference to the actual time. Does that make sense now?
Okay.
All right, Sister Confidence, can you bring your hands down, please? If you don't have any question, so you don't get me confused. But if you have questions, go ahead and ask. So the next journey is from B to C. Rachel, are you on this call? All right, because your the words you use was part of the motivation why I had to encourage myself to be here. Thank you for that very words. So B to C, now let's take the slope for B to C. So for your B to C is the distance, take your slope, your gradient from here through here to this point, right? That's your gradient, getting the slope. Now, which implies that this will be your x2. Sorry, this will be your x1. Now, trace it up to this side. That will be your x2. Then to the other side, that will give your x1. So that said, my y2 is 45, and my y1 at this point is going to be 30, right? So I'm going to have that my speed for that very region, the speed for that region, speed will be equal to 45 minus 30 divided by 4 minus 2. So that the speed for that very section of the journey is going to be equal to 30 minus 45 should give me 15. 15 divided by what? By 2. So that the speed of that very journey at that point, the speed will be equal to what? 15 divided by 2 should give me 7.5 kilometer. Okay, I used kilometer before. I'm writing meter per second or kilometer per hour, please. So be consistent with your timing. Check what was given to you. Physics can play around with unit a lot. So this will be kilometer per hour. Kilometer per hour. All right, so that said, we can now find the speed of the last part of the journey, which simply means I'm getting on that gradient or slope. I like using the big triangle, so I will take it downwards this way, then roll it over to this side. So here is 45 minus what? 0. Then something will change. Remember that the side that takes your x2 is the 90 degrees angle. The side that has the 90 degrees is the side I usually take x2. Now observe this time around, look at where the 90 degrees is. That thing is a negative slope. You must have done negative slope in physics. That same concept is still valid even here. So this implies that I'm going to have that for that region from D to E, as the case might be, D to E. What that's negative means, why it has negative means that the guy is doing what? He's slowing down, right? He's coming to rest. He's beginning to apply his brake. That's why you have that negative slope right there. So from D to E, my speed at that point in time will be a negative slope, right? So which means that my x2 will be smaller than my x1. So the value here is 45 minus by what? X1 is 0 for the y-axis. So 45 minus 0 divided by, on the x-axis, we have 6 minus 7, because here is your x2 and this is your x1. And that is why it's going to be a negative value. So 6 minus 7, so that the speed is equal to 45 divided by negative 1. So speed is actually, you have to put is 45 meter per second per se. Do you understand? But that negative sign is telling you that the guy is doing what? Slowing down, right? Just like when you have deceleration. Are we together, guys? Someone is asking me where are they doing it, the class. Interesting. So I'm coming. Let me respond. You know, some of us can be funny. Let's quickly do the needful so that on the judgment day, when they will ask me whether I carried my task very well, I will say yes, that I did. All right, so that's it. That's how to calculate the distance, the speed. The speed will give you the gradient of at every point in time will give you the speed covered. Does that make sense? Are we all on the same page? If we are all on the same page, can you kindly give us a thumbs up before we proceed? Everybody, a thumbs up. Let's know that we are all on the same page. Are we all on the same page? Thank you, Hosanna. Any questions so far, guys? Mess, are you still here? In confidence, are you here? Where are others? Paul, how are you doing, Jerry? Sorry, I've not actually checked up on you for some time now. How are you doing? Yeah, Paul, can you hear me? Okay. So let's proceed to velocity time graph, having covered distance time graph. I was mentioning some names before, just to be sure. Yeah, Justice, are you following? Meso, how is it going? Paul, hope you are good. I was asking. Yeah, yeah, good. Lillian, hope you are fine as well. Lillian, hope you are following. So can we move over to the next one now? We're done with distance time graph. So that's the most they will ask you, right? When it is constant and the rest of them. That's the most. So they can ask you from your distance time graph. So that said, let's proceed to velocity time graph. So just look at questions you can actually ask there, right? And find them. Always you can just trace the lines. It's not a big deal. Like it's not something that should to worry you, provided you know how to read the values. I would have loved to solve some questions, but let's look at velocity time graph before I will do that. Okay. Now for a velocity time graph, it can also be called velocity time graph. Now you are plotting speed against time, right? Are you seeing the difference between them? Distance time graph, you are plotting distance against time. Velocity time graph, you are plotting velocity against time. Are we together? So let's see. I want to use the same line for them so that it make everything easier for us. Yeah, somebody can actually start checking questions that we can answer on this, right? If you have any questions you can actually get for us to solve under this, then you can do well to get them so that we can get our hands dirty right away. So start checking if there's anyone, then can work on that. All right. So next one is velocity time graph. Don't worry, you're going to get the note. So in case I've moved past you. So what is a velocity time graph? It shows the motion of an object against time, right? The motion. The other one is showing you the distance an object has covered, but this one is telling you the motion, how the object is traveling, right? So it tells you the motion of an object against what time. So it is usually in kilometer per hour as well. Remember that there's a difference between your speed and your velocity, like I said earlier earlier on, right? So what are these things you are going to see to always remember about your speed and your distance time graph? So as always, let's assume that we have a graph this way. Let's assume that we have a graph this way. So let me have my velocity time graph. All right. So let's say we plot our line as always. All right. So let's sketch. Let's say we have 0 here. Let's have 10 here. Let's have 20. Let's have 30. Let's have 40. So let's have here to be 1, 2 centimeter, 2, here 3, let's here be 4, here 5, here 6. Remember that for this one, you are plotting speed against time. Do you understand? That's your velocity time graph, right? So here, you are plotting your speed or your velocity against time, right? So that's your velocity time graph. Or let me write it as velocity, please, so we don't get things mixed up. So here is your velocity. So you are plotting velocity. Remember, velocity is what? Meter per second. Is that not so? Here is time, which can be second, it can be kilometer, and the rest of them. So the first thing I want you to know, if the journey, let's say we have a straight line this way, right? And meanwhile, the gradient of a velocity time graph will give you the acceleration. Just like the gradient of a distance time graph will give you speed because distance over time is speed. Now, velocity over time is acceleration. So the gradient of that will give you the acceleration, right? So once you have a straight line this way, it means that you have, okay, let me complete the journey before I start talking. So let's have something this way. And when I do that, let's bring it down to rest here, this way. Now, what am I saying? You will see that there are two parts of this journey, or three of them. let me have my tiny line coming through here. Let's have my tiny line coming through here. All right. So now there are three sections in this very journey, three of them. This is the first part of the journey, journey one. This is the second part. This is two. And then this is what the third part. Now, what are the things I want you to know? For the first part of the journey, for the first one, number one, what is happening right there? You are going to see that you have a constant what? Acceleration, right? So here you have that straight line. So this is your constant acceleration. Why is it constant acceleration? It is constant because at that point in time, you have the gradient. The gradient of this, the motion here tells you that it is constant when you have that straight line at a constant acceleration, equal velocity at equal interval of time. Then at this second part of the journey, right? At this second part of the journey, that is two. What happens there is that acceleration is what is acceleration is equal to zero. Do you understand? Because of what? Remember what I taught you in the other class, that when velocity is changing, it means that acceleration is changing. But when the velocity is not changing, acceleration is not changing. Is that not so? So if you check here, you see that this is a straight line. It's at 30, but here it was increasing 0 to 10, 10 to 20, then to 30. It got to 30, velocity stopped changing, which means that here, your acceleration here is equal to what? Zero, right? So here, acceleration, or call it zero acceleration. So zero acceleration. And for zero acceleration, do you know what it means? If you have zero acceleration, it simply means that velocity, you have constant velocity at that point. You have constant velocity. Now, the third part of the journey, if you observe, for the third part of the journey, right, what happens here at the third part of the journey is deceleration. It is coming to rest, it is coming down, and it's usually a negative slope, right? A negative gradient. So for one, it's going to be positive gradient. For two, is zero. There's no gradient. For the third one, is a negative gradient. So here you're going to have that the third guy at that point in time is what we regard as what? As your constant what? Deceleration. Or you can call it what? Retardation. You guys must have heard all of these things. Constant acceleration, or in brackets, retardation. And at this point in time, we're going to have a negative what? Gradient. Remember that here, we're going to have positive gradients. Positive gradients. For this side, you have zero gradients. And for this side, we have a negative gradient. Now, there are two quantities you can estimate from your velocity time graph. Unlike your distance time graph that you can only estimate the speed, right? For velocity time graph, you can estimate the acceleration and you can estimate the distance traveled or displacement, right? So for now, for the acceleration, you just have to look at your gradient. So the gradient of the graph will give you the acceleration, but the area under the graph gives you what? The distance traveled. So now note that gradient of a velocity time graph gives the acceleration of motion, gives the acceleration of the object. That's the first thing I want you to note. Then the second one is that the area under the graph, gives the distance by the object. Now, do you know what that implies? That if I want to get the distance traveled, permit me to copy this and paste again so that it will be easier for us to understand better. So I've spoken about the acceleration. Now let's speak about the distance. Let's speak about the distance traveled by the graph. All right. So now for distance traveled, if you want to know the distance traveled from this 0 point to point A, total distance covered by the body from, let me label them, from 0 to A to B, and B to C. Distance covered from 0 to A, how do you calculate it? It's just the area under the graph. So here is my A1, here is my A2, here is my A3. So area of this very graph here will give me the distance traveled between 0 to A. If you understand what I said, give me a thumbs up. From 0 to A, that will give us the distance traveled by them. Are we together?
Your voice is low. Wait,
I didn't hear you.
your voice is low. No,
Is it true? Or that's confirmed? Is my voice low? A thumbs up if my voice is low. I don't think so. I'm using my headset, and the headset amplifies the sound. Any other person that my voice is low from their end, verify. Let me work on it. Another person. Now, if my voice is loud enough from your end, give me a thumbs up. Okay. Only Rachel. Any other person? Lillian, is my voice loud enough? Justice, how about now? The sound is breaking. Interesting. How about now?
it's better now, but sometimes it will break, sometimes it will come low, and sometimes it will be normal.
Okay.
Oh, no.
Okay. Okay. Is it my own network? I don't know. But then anytime it happens, let me know. Are we all on the same page now? Okay, makes sense. So now the area under the graph will give you the distance traveled. Where are others? Have they left the call? They left. Are they tired? They are sleeping already. Yeah, it's going to be a quick one. By 11:30, I should be done. But I want to be sure that I'm done with velocity time graph. So in the next class, we'll move. So now the distance traveled between 0 to A, right? Um, so distance from 0 to A. Distance from distance from sorry. Distance from point 0 to what? To point A. So how do we calculate? It will give me area under the graph, right? And the area under the graph is a right angle triangle, is that not so? So A1 will be equal to half base times height. Now you are going to check the base. Look at that triangle right here. I can just bring out the triangle, then draw it this way, then cover it up this way. Now find the distance. Now the height here, check. The height here, height of this triangle is 30. Are we together now? 30. Then you subtract the distance, right? So here will give me the height right here. Total distance here, this is the height, and then this is the base. So once you plug in those values, you have the area of the graph, and that area will give you the distance traveled for A1. Now the next one is the distance for A2, which is the distance from A to B. If you observe from A to B, you will see that we'll have kind of a rectangle right here that looks like this. So your A2 is going to be what? Length times by width. So what are you going to do? Calculate this distance here. Here is your length. Here is your width. You calculate. So this one is your height. This one is your base. Do you understand? So distance between here to here, subtract it. Let's say here is 2.5. So 2.5 minus 0. That will give you the base. The height is what? 30. From here to here is 30. Then for this our length. From here to here is 4. Here is 2.5. So 4 minus 2.5 will give you the what? The length, right? I don't know the one that is length again and width, but anyone you interchange, you're still going to get the same answer because multiplication is commutative. So now this length is also 30. So 30 times the distance you have here, you have the actually what the distance traveled for the second part of the journey. Now for the last part of the journey, right? Let me demarcate this. So for the distance for the last part of the journey, we'll have distance from where to where? I think from B to C. From B to C. What do we have right there? Distance from B to C. All right. So now for that distance from B to C, you could see something right there that will have a right angle triangle. So I'm going to bring it down. I have my rectangle triangle this way. I have this way. And I have this way. All right. So the same thing, so that A3 is equal to what? Half base times height. As always, you could observe where the height is and where the base is. So this is the base, and this happens to be the height as well. So let's use H1 here, let's use B1 here, let's use H2 here, and let's use B2 right here. So which means I have H2 here, I have B2 right here, B1, H1, right? So this is our B2, this is our H2. So that will give you the area. So that area there gives you the distance traveled between B to C. You've seen how to get the speed. The speed is simply, the acceleration is simply the gradient of that very line. Once you get the gradient, I've explained how to find gradients from the other line, from during the distance time graph. I've shown you how to actually find the gradient, right? So that said, this is what you need. Now, if you want to get the total distance traveled, how do we estimate the total distance traveled from this very graph? Now, what you are going to do for total distance travel for the entire journey, right? Total distance travel for the entire journey, total distance traveled for the entire journey will now be equal to A1 plus A2 plus A3. Are you seeing it now? When you add the areas together, you are getting the total distance traveled. So that the average speed is equal to average speed for the entire journey is going to be what? Total distance traveled all over what? The total time taken. So having said that, what that implies is that the average speed at this point, from what we've estimated, the average speed will now be equal to A1 plus A2 plus A3 divided by what? Total time. Now, are we on the same page now? So these are key things you need to remember about your velocity time graph and about your distance time graph. So in summary, right, if I start from what I did earlier, remember this is your distance time graph, right? So let me put it down right here. This is your distance time graph. All right, so for a distance time graph, I've explained what happens right there and everything that we need to always remember at every point in time. When the object is stationary, when the object is moving, what do you need to remember? And I said that the area under the graph, for a distance time graph, area gives you, the gradient equals your speed. That's one thing I highlighted, which I want you to always remember, that the gradient equal speed. That's the first nugget. Now the next one, I went ahead to explain how to find the gradient for each of them, speed, distance over time, for the first part of the journey, for the second part of the journey, right? Then we went ahead to your velocity time graph, and I explained what it should look like. When it is slanted this way, when there's a straight line, means that you have zero acceleration. Zero acceleration means constant velocity. Acceleration is not changing. And I made this introduction during our first class when I said that acceleration is dependent on two things, the speed and the velocity. You've seen that come into play. And remember, when you are going to have a negative gradient, which means you have deceleration. And I said, note that the gradient of a velocity time graph gives the acceleration of the object, and the area under the velocity time graph, I spoke about the gradient. This is your gradient right here. And then I also said that the area under the velocity time graph gives the distance traveled by the object, right? And after that, I give an example. I spoke about the how to get the distance traveled for each of them. Sometimes it can form a trapezium. You understand? So you add everything together, depending on what the graph looks like. It can be a trapezium, it can be a triangle, but basically it revolves around trapezium and triangle. So look at the shape of the graph, then you add them accordingly. Does that make sense? So A1, A2, A3. That's the way you can estimate. If they ask you about the average speed, just add them together, total distance traveled over total time, so that the average speed is equal to A1 plus A2 plus A3 divided by total time. Any question at all? Do you understand everything, the concept and what it entails? Are we on the same page? A thumbs up if we are on the same page, please. A thumbs up if we are all on the same page. Nobody responding. Is my voice still cracking? Hello, Justice, can you still hear me? Lillian, are you still here? Meso, who is confused? Okay, Meso is here. Good. Suzanne, are you following? Adeni Joseph, are you here? Benita, sorry, the way I'm pronouncing your names. Yeah, I hope everybody is on path and intact with us, and we're not leaving anyone behind. Suzanne, the Lord will strengthen you. Amen. You understand? So get the recordings and watch them. By tomorrow morning, recording should be ready, like as fast as possible. Recording tomorrow morning should be ready. So, why is the velocity time graph retarding? Why is it just a little bit confusing? Okay, now you are coming to rest. You are coming down. That's why it is that way. Deceleration. When you start applying your brake, you are coming down. You get so that's why you have that negative retardation right here. But you see the same thing, just that it has a negative sign because of the slope. Now, if you have a graph this way, I think it revolves around you understanding something, that when you have a graph this way, when you have a graph this way, and the line is this way, you will see that this will give you a positive graph. This is a positive graph, positive gradient. But now, if you have a line this way, if you have a graph this way, let me use a small place. You have here this way, and the graph is like this. The line is like this, backwards. Observe something about that. This one is like this, but this one is like this. Sorry, this way. I wanted to draw it. So this is a negative graph. This one is negative. Why this one is positive? So it's because of how they are slanted this one, slanted that way. Are you seeing it now? So because when you take the gradient of this one, angle 90 is going to be here. And usually here is your x2, here is your x1. Here it doesn't change, y2 and y1. But observe this one that is a negative graph. Look at what will happen to it. It will be like this, for example. So if I take the slope, let's draw here down. You will notice that your x2, this place is always your x2. You have here to be x2, here be x1. You're going to see that your gradient says that m is equal to y2 minus y1 over x2 minus x1. Here, x2 is bigger. So x2 minus x1 will give you a positive number. But look at this one, x2 is smaller because of how the whole thing is. This one is like this one is like this. So I believe that that is clear now. So what I want you to do for me is to get questions along these concepts of what we've treated. Because of the time, I will let us go. Then I want you to go check out for questions that has to do with this concept. When they say find the distance traveled, when they say constant acceleration, but anything they're going to ask you revolves around what we just did right here. The next one I should explain is your acceleration. Okay, let's stop here for now. So let's just picture all of this, your distance time graph and your velocity time graph. So if you have any questions on that, feel free to ask me after watching the recording. But I want to beg us to go look for past questions regarding all of these concepts. But the concepts revolves around this. It can be more than this. Know when you have constant acceleration, know when you have no acceleration. So zero acceleration means constant velocity. And with all of these concepts, I believe that we are fine. Yeah, and I'm glad that we got this right. And I'm glad I achieved my goal today by hosting this class. In as much as I was tired, and some of us we are tired as well. So let's keep pushing, guys. And I wish us a beautiful night rest. You can take time to get questions on this online on your graph. The young man I sent to get the past questions for us, he got it, but now he has not scanned it. I don't know why. He has not done that to scan and send to the group chat. So all the best, guys. Yeah, give us a love emoji if you enjoyed today's class, and then if you understood the key things. Velocity. I say, give me a love emoji, others or someone is laughing. Good. Thank you. We are all good, right? No questions, right? Yeah, no questions, and everybody's fine. Right, let's keep pushing, guys. One thing about all of this thing is that you have to sacrifice something to get something. It's something I posted the other day. That was my matriculation around 2018, February. That's the day before yesterday. I posted on my status and I wrote something. I said, if it costs you nothing, then it means nothing. So I remember the sacrifice, how we struggled back then to pushing for chemical engineering in Futo, the late nights studying from 9 p.m. to 4 a.m. every day. I will go to the church in the morning, read from 9 to 6 p.m. So all of those sacrifices, and good enough, they are paying off. Some things I'm teaching are things I read back in the days and the rest of them. So let's keep pushing. You'll be glad you did. You look back at the whole stress, the whole effort you are putting in. There's nothing like, there's this joy and satisfaction that comes when you achieve your goals, and when you know that you gave in your very best. So guys, I'm rooting for us, and I sure do hope that the results will come out fine. All right, all the best, guys. My voice is cracking already, showing that it's late. Yeah, thank you, everyone, and I appreciate each and everyone. By 4 a.m. now, I'll still go and wake up people by 4 a.m. God should strengthen me, man. But it's entirely fine. All right, guys. All the best.